Hello everybody, this is 2014 question number 3 for both Calculus AB and BC. It's a graphical analysis. Let's do this. So we have a function f, so clearly that's f. And it's a closed interval, therefore you have the dots at the end. And there's 3 line segments, and you have a function defined as g of x. So for part A, we want to find g of 3. So I can do that right here. Part A, g of 3. So in this equation they gave us down here, replace this x with 3 and that x with 3. So we end up with the integral from negative 3 to 3 of f of t dt. So how do I find that? You should know if you have a graph, the integral is just the net area. So you want to start here and end here. It's going to be this area minus that area. That would be the net area. So let's do some fancy schmancy math work. That's going to be 1/2 the base times the height. This distance from here to here is 5, that's the base. The distance from here to here, 1, 2, is 4. So that's the area of the first triangle. Then the second triangle is going to be 1/2 the base. From here to here is 1. Now the question is, what's that distance there? So in order to find that, we need to know the slope of this line. So if you look, the slope goes down 1, 2, 3, 4 over 2. So the slope of that is negative 4 over 2, or negative 2. So therefore, this point here, if you move over 1, you're going to go down 2. So that's going to be 3, negative 2. So that height, so the base is going to be 1, and the height is going to be 2. And I messed up. That's minus because that's a net area. So you're going to subtract that. You should leave it like that. You shouldn't simplify that. That answer's perfectly fine. For you foolish people that insist on simplifying, it will come out to be 9. But don't do that. It's not necessary. Just not necessary. All right, let's continue to part B. I'm going to erase some of all of this stuff I did here. Part B. You want to know when G is increasing and when G is concave down. So in your brain, the thought process, G is increasing when G prime is positive, and G is concave down when G double prime is negative. So that's what we're looking for. So therefore, we need G prime and G double prime. So we need to show that. What is G prime of x? So if we look at this, sorry about that, G prime of x, you're taking the derivative of an integral. And very important here, is from a constant to your actual variable of your function. We learned the fundamental theorem says if you take the derivative integral from a constant to the variable of your function, you just plug that variable in for t. And so that, wonderfully, is just f of x. Now, to get the second derivative, well, we take the derivative of both sides. G double prime of x is just f prime of x. So now we need to know when f prime is positive. F is positive because G, it won't erase. There we go. F is positive, and when f prime is negative. So look at the graph. When is f positive? I will highlight with a beautiful, purple. So in this region here, F is positive. Do I have purple? Yeah. So there, F, which is G prime, is positive. And that's what I'm looking for, right? I'm looking for that. So F's negative over here, but I don't care because we want to know when it's positive. So let's look at this one. I want to know when F prime is negative. Well, I have F. When is F prime negative? F prime's negative when F is decreasing. So in a beautiful red, yeah, I'll do red. When is this function decreasing? I'm going to do it off to the side here and here. So in red, what do those represent? The red represents where F prime, oh, let me do this differently, yeah, where F, not F prime, where F is decreasing. So this is what we're going to write off to the side here. I'm just showing you the logic. Therefore, that implies F prime, which is G double prime, is negative. Because if a function is decreasing, its derivative is negative. So that's the region we're going to look for. We want both of those to be true. So now we have to write that out in English. We need to write and speak in math. So let's do the purple part first. So we're going to say F, which equals G prime. Okay, nah, I actually lied to you. Whoa. So let's look at this. I'll actually give you the logic over here. So therefore, G is increasing on this region. So that's what I'm going to say. G is increasing on the interval from -5 to 2. Now, you could break it up from -5 to -3, and then from -3 to 2, because technically the slope is 0 at this point. But if you were to graph it out, it's actually increasing over that space. But if you were to split it up, you'll be fine. But I'm just going to do it as 1, because I'll show you why. I know you guys are like, come on, let's move on. Let's get through this video. But the function's increasing from -5 to -3, okay? Increasing. And then at 3, it's flat, and then it starts to increase again all the way up to here. So that's what the function looks like. So at that point, even though the tangent line is 0 right here, it's still increasing to the left, increase to the right. So at that point, even though the tangent line is 0, it's still increasing through that point. So again, you could have it separate or together, but we need a justification. Why? Because F, which equals G prime, is positive. El Dano. So let me add something here. Here. If G double prime is positive, that implies G is concave, oh, negative, sorry. It's negative, concave down. So we're going to work through this backwards. This is what we want to get. And we have to go through the justification going that way. All right. Or we can go, actually there's 2 ways to do this. Actually, we're going to go this way. I'm again a liar, liar, pants on fire. There's a lot of ways you can write it out. But we're going to start here and work our way that way. Just to give you a twist on how you can write things. So f is decreasing on the interval from -5 to -3 and from 0 to 4. So -5, -3, and from here 0 to 4. That's a statement. Therefore, f prime, which is g double prime, is negative. Now that I don't, let me see. Therefore, it's negative on those intervals. Okay, so if it's negative, our next conclusion, therefore, G is concave down on those intervals. Okay, so we connected this. F is decreasing on those intervals. Therefore, F prime is negative on those intervals. Therefore, G is concave down on those intervals. If you wanted to, you could say because G double prime is negative on those intervals. Now, in my book, you probably don't need that because you have this therefore. And what's that therefore? It's based on what you said previously, which you already stated G double prime is negative. So this one is not necessary, but if you just want to be sure and emphasize that it's because G double prime and not the F prime that causes that, that's fine. So now we can conclude another therefore. Therefore, G is decreasing and you like how I interchange my print and script, and concave down on what intervals? So it's going to be where it's both purple and pink. -5 to -3. And they're both from 0 to 2. That is my answer. Done. That was pretty long for part B. Let's move on. Part C. Should I clean this up top? I will clean it up a bit for you because it is a mess of writing. Okay. Yeah. There we go. C. You want H prime at 3. So therefore you want H prime. Now what you need to recognize this is a quotient rule. So first let's apply the quotient rule. It's going to be low D high minus high D low all over low squared. Now we want H prime at 3, so plug in a 3 everywhere. It's 5 times 3 times G prime at 3 minus G at 3 times 5 over 5 times 3 squared. Now we can replace stuff. Well, we know that's 15. Actually, you don't have to simplify that. Let me do that. That's a bad example for you guys. That's going to be 5 times 3. G prime of 3. We're looking for G prime of 3. And G prime. Okay, let's look. G prime at 3 is just F at 3. So I'm going to say F at 3. Oh, we found that earlier. It was -2. We did that earlier. Minus, oh, that's not minus, times -2. Minus, now we want G of 3. We did that in part A. In part A, G of 3 is 9. So we just place a 9 there times 5 over 5 times 3 squared. That's your answer. Leave it like that. Don't simplify that. There's a high probability you might make not a high probability. There's a chance you might make a mistake there, and you'd be sad to lose those points. Now, I'm going to do this because I know some of you insist. Please don't do that, but if you do that, that's what you would have gotten, but I know you guys are smarter than that, and you wouldn't simplify that. So that's part C. Let's do part D. Party! Woo! Party. This is P. Find the slope of the tangent line of P at -1. So a couple concepts. Slope of the tangent line, you should know that's a derivative. So in other words, it's asking for, I'm going to reinterpret this. This wants P prime at 1. So the first thing you have to show them is you know how to find P prime of X. Well, what's going on? You should recognize you have a function in a function. So the function on the inside's box. So what is the derivative of f of box? It's going to be f prime of box times the derivative of box, which will be 2x minus 1. That's the chain rule. And now we just plug in 1 for x. Every x you see, you plug in a 1. 1 squared minus 1. 2 times 1 minus 1. And I get f prime at 0, 2 minus 1. I know it's tempting just to write a 1 there, but I'm not going to do it. Not going to do it. Uh-oh, I think I messed up. This thing's telling me I messed up. Is it -1? What's going on? Oh, it's -1. It's -1. Estupido. -1. I'm glad. -1. -1 squared. -1. -1. Whew. Whew. Scary. That changes everything. So that's going to be 1 plus 1. That's going to be 2. And then that's going to be -3, but you don't have to simplify that. Yeah, I'm going to leave it. As an example to you, just leave it like that so you don't do something extremely stupid. All right, f prime of 2. That's the slope of f at 2. What's the slope of f at 2? Well, the slope of this line we found earlier is -2. So we get -2 times 2 times -1 minus 1. That's your answer. Leave it. Stop. Don't do it to yourself. Don't simplify it. We're done. One more to go for today.